Hey, Professor Caps, it's Michael James here doing week two's lab. I'm going to go ahead and show you my raw materials. Then I'm going to pause the video while I make solution A and solution B because they are time consuming based off what I learned from watching the presentation posted on Blackboard. So what I've got here is I've got my iodine solution right here. It's a 10% solution. I've got some cornstarch. Um, Let's see. I got some vitamin C tablets. Now these are 250 milligrams, so it looks like to get my 2,000 milligrams, I'm gonna have to use 8 of those. What else do we have here? I've got a mortar and pestle, which I'm gonna use to break up my vitamin C so that I can increase the surface area and hopefully get it to dissolve. I've got some distilled water, which I've heated up. And I also plan to heat both of my solutions A and B after I'm done mixing them, because if we increase the temperature, we're also going to increase the rate of reaction. So I'm going to go ahead and make my two solutions right now, and then I'll pick it back up as soon as everything's complete. So Caps, picking it back up, I just wanted to show you this real quick. I'm in the middle of making my solution A right now. I've put my distilled water in there, and I've crushed up my vitamin C with a mortar and pestle, and it's a very fine powder. However, I'm getting a foam layer on the top. I'm not sure if this liquid is super saturated at this point and can no longer dissolve the vitamin C. I did use 2,000 milligrams. I'm going to continue to mix it for a little bit, see if I can't get it to completely dissolve. However, I just wanted to note that just in case it has implications on my results. I'm going to pick it back up just to show you. This is my filtered vitamin C. Now it's still a little hazy in color. I wanted to show you this because I think it's really cool. So I'm adding in my iodine, and if you notice, it's a thick brown liquid. But when you put it in here, it dissolves completely. I thought that was pretty cool to note. All right, so I have made my two solutions, solution A, solution B. Got my stopwatch here. I'm going to put it off to the side. Now what I've done is I have mixed everything together, and then I went and heated both of my solutions up to close to boiling, and then I transferred them into these two souffle cups just for simplicity while pouring. Now, what I do have here is a clean glass that I've not used before. I've got equal amounts of both solution A and solution B. I guess I should tell you what's in the solutions. Let me pull that up real quick. Let's see. All right, so in solution A, I have 2,000 milligrams of powderized vitamin C, which I crushed up in the mortar. I have my iodine solution. It's 10% iodine. So what I did is I put in roughly about 12.5 milliliters. And then I have about 60 milliliters of distilled water. And then on top of that, I had about 5,000 milliliters of distilled water. And now I just have about a portion of that, about 100 milliliters, I would say. And then in solution B, I have roughly a half gram of cornstarch, 350 milliliters of distilled water, and then I have 150 milliliters of my 3% hydrogen peroxide. All right, so those are my two solutions. I am going to pour them in. Okay, start my timer. Let's see here. Now I'm going to mix and see if we can. Oh, whoa. Oh, did you see that? That was cool. Holy moly. I thought it wasn't going to work for a second. Wow, so that took me about 22 seconds. It's amazing how fast that happens. So both the solutions were colorless, and then when we mixed them together, there was a color. So the color is from the iodine, which is I2, but when it reacts with the vitamin C, it becomes iodide, which is colorless. Um, so when we put A and B in the same beaker, solution A has vitamin C and I minus ions. Solution B has hydrogen peroxide and starch. So we've got two competing reactions here. I2 starts to accumulate. It forms a triiodide plus starch, and that's where you're going to get your blue color. So if the concentration of let's see, if the concentration of I minus or the hydrogen peroxide is increased, the rate of our reaction is going to be increased. And also, if we increase the temperature, like we saw in my reaction, the rate's going to increase as well. So I would have expected for this color change to happen less quickly if I didn't boil. Also, if I had decreased my hydrogen peroxide, maybe if I put in 50 milliliters or 100 milliliters, it wouldn't have happened as rapidly. Again, that was a really cool experiment. I didn't expect it to work because I had some issues with filtration because both of my solutions had excess byproduct from whatever they add into the vitamin C pills, or maybe some of the cornstarch wasn't completely saturated. So I wasn't expecting this experiment to go as smoothly as it did. I'm happy with it. I'm happy with the results, and I hope you enjoyed it. All right, thanks, Dr. Caps.